So as we move towards disentangling these costs, it's useful to think about them in two ways, variable and fixed. Total just means the sum of variable costs and fixed costs. And again, note that notation, VC for variable, FC for fixed, and TC for total. So these definitions are fairly straightforward, but they're going to help us as we think about time horizons in the future. Variable costs are costs that change with the rate of output. Earlier, we gave the example of labor. If we want to produce more output, we're going to need to hire more workers. Workers are a concept of variable cost. If I want to hire an additional worker, it's going to cost me more money. This varies with the rate of output. Fixed costs do not vary with the rate of output. And a good example here is one we used earlier, rent. So if I am producing something, I still need to pay the rent on my building. That rent doesn't go up even as my business becomes more popular and more successful. Even if I stop producing, if my output is zero, I still have to pay my fixed costs. Fixed costs exist even when quantity output is zero. Fixed costs do not change as output changes. Summing these two together, we get total costs. These are simply the sum of the variable and fixed costs. And it's key here to take note of that notation. TC equals total variable cost, TVC, and total fixed cost, TFC. From here, we can begin to think about time horizon. And this is something we've been hinting at throughout the semester. What is the difference between short run and long run? John Maynard Keynes joked that in the long run, we're all dead. But now we can actually put a finer point on it. We can formalize that definition, which is the long run is the period of production in which there are no fixed costs. That means all inputs are variable. So let's think about rent. I have to pay rent for my business, even when I'm not producing. But in the long run, I might be able to move to a new building. I might be able to negotiate that rent down. In the long run, even something fixed by contract like rent becomes negotiable and variable. It can be helpful to think about this from the opposite standpoint, which is in the short run, there is at least one fixed cost. The short run is the period of production in which one input or more is fixed. So again, think about businesses you know in your own life. They are probably operating in the short run right now. They probably have at least one fixed cost, for instance, rent. From here, we can begin to think about averages. Here, averages means the same thing it's always meant, just an arithmetic mean. So we divide by quantity. To get the average total cost, we take all our costs and divide by the units of output. Remember, total cost is just the sum of fixed and variable costs. To get the average variable cost, we ignore our fixed cost and only divide variable cost by that output, by that quantity. To get average fixed cost, we take our fixed cost and divide it by quantity. And to get our marginal costs, we take the change in our total cost and divide it by the change in quantity. It can be useful to think about these costs in terms of a table. And it can be useful to think about costs in terms of our total output. So this first column, Q, quantity, just shows our output. And this business here is producing anywhere between 0 and 100 units. Notice that variable cost changes with our output. So when we're not producing anything, when output is 0, we have no variable costs. Why would you hire workers to make no output? But total variable costs increase with output. More production means greater total variable cost. TFC, total fixed cost, is the flip of that. Fixed costs do not change with output. Even when we're producing nothing, our total fixed costs are still the same. In this case, $100. This next column, total cost, is just the sum of total variable cost and total fixed cost. So when we have no variable cost, we still are paying our fixed cost. Our total cost is $100. And as variable costs increase with output, our total costs also increase with output. Keep in mind that since mathematically total cost is just the sum of total variable costs and total fixed costs, there is this direct relationship between quantity and total cost. As we move from total cost to average cost, it's important to note that we can't compute averages when output is 0. Mathematically, it makes no sense. This also applies when we're thinking about marginal cost. Again, marginal means additional, and it doesn't make sense to think about additional when our output is 0. Average variable cost, total variable cost divided by the output, is going to be U-shaped, and we'll see more on this in the next lecture. But it's important to recognize average variable cost, total variable cost divided by output, divided by quantity, is U-shaped, and we'll see more on this in the next lecture. But it's important to recognize that we will see a minimum point in average variable costs. We will see other minimums as we move throughout this table. Average fixed cost is not U-shaped, and we can think about this when we think about the math behind it. Since fixed cost isn't changing, adding quantity is only going to drive average fixed costs down. We see it hits its minimum at the bottom of our table. Average total cost is also U-shaped, and it can be found one of two ways. Either dividing our total cost by the output, or summing our average variable costs and our average fixed costs. Because of this, we'll note a couple things. One, average total cost is greater than average variable cost, and the amount by which it's greater is our average fixed cost. And two, average total cost hits its minimum below average variable cost. Average total cost will hit its minimum at a greater quantity than average variable cost. And this minimum that it hits is known as the efficient scale. A firm is producing efficiently when its average total costs are at their minimum. Finally, marginal cost is also U-shaped. Again, we will describe these shapes more in the next lecture. But mathematically, marginal cost is the change in total variable costs divided by the change in quantity. Remember, delta means change in mathematical notation. And note how the change in quantity in this table is always 10. So, when we add $30 of total cost, when the change in total cost is $30 and the change in quantity is $10, our marginal cost is $3. It costs us $3 to increase a unit of output. Also note how because fixed costs are not variable, marginal costs are only a function of that change in total variable cost. In previous lectures, we talked about this concept of diminishing marginal product. And when marginal cost starts to increase, that is where marginal product is diminishing. So with an eye towards calculating cost, here we have a table with some given information of costs and quantities. What I'd like you to do for next lecture is try filling this out on your own.